this really is a perfect follow-on from the previous talk around observability and OpenTelemetry. And so Ramon is the VP of our observability team here at Timescale, working on and managing the Prometheus project, the Promscale project, which originally based on Prometheus. And so, just go ahead and lead in. You can tell us a little bit about yourself and what you're going to do today, Ramon.
Sure. Yeah. So my name is Ramon Guiu. I'm based out of beautiful Barcelona. And as Ryan said, I'm a VP of product of observability products at Timescale. And I come from New Relic. So I joined Timescale 8 months ago. I come from New Relic. I spent 4.5 years there managing different teams on doing infrastructure. New Relic is a well-known vendor of observability and monitoring solutions.
Right.
And today I'm going to talk about what you can do with trace data. So Scott in the previous talk shared a little bit about observability, how trace data is important. So I'm going to show how you can use trace data in SQL to do some wonderful things and get amazing insights from, to better understand the behaviors of your systems.
Very good. All right, share your screen.
I'll go ahead now.
I love every time that anytime we talk about it, we say trace and observability plus SQL. Like, it's just not what most people expect. And I love that we can add that SQL part on. So this is exciting.
That's great. Yeah.
All right. I'll join you afterwards. You go ahead and have a good time, and we'll come back for some questions.
Sounds good. All right. Okay. So yeah, I mean, as more and more engineers adopt microservice architectures and cloud native technologies, understanding the behavior and failure patterns of our systems is key to ensure they are performing and delivering a great customer experience. Okay. So the problem with that is that it's really hard because those environments are made of many components and they are highly dynamic with auto-scaling and frequent deployments of new versions of our applications. And this is why observability is needed. If you think about it, observability is fundamentally an analytics problem. You collect a lot of data without metrics, logs, traces, events, maybe other things, like profiling data. And the thing is, you need to analyze it often in real time so that when a problem occurs in production, you can quickly query and analyze your data in any way you need to get answers to the specific questions that are relevant for that incident. So in this session, I will use a simple microservices demo environment that we've built to show you some of the invaluable insights that you can get about your systems by being able to query and analyze your traces using SQL. And for that, we will use 3 open source projects: OpenTelemetry, which again, Scott has talked about in the previous talk; Grafana, who everybody knows about; and Promscale, which is a tool a product we're developing at Timescale. This is the agenda. Because OpenTelemetry was already covered in the previous session, and Grafana, I guess pretty much everybody knows about it. I will just give a short introduction about Promscale, and then I'll jump straight into showing what the demo environment looks like and the actual querying using Grafana trace data. By the way, the demo environment that we're going to be using is available on GitHub. You have the URL there. You can go and download it and use it. And we've also written a detailed blog post that covers everything about that demo environment: how to set it up, how to instrument your code with OpenTelemetry, how to query the data, and build Grafana dashboards. I'm going to be covering especially the querying part of that is covered in the blog post. And in the blog post, you'll even go into more detail than where I'll go today. So I'll encourage you to check it out if you're going to dig deeper into querying data, OpenTelemetry, and querying data traces using SQL. Okay, so the demo makes heavy use of Promscale and its capabilities. But what is Promscale? Promscale is an open source observability backend for metrics and traces. Okay, so it's one single backend for both, and it's powered by SQL. And it's powered by SQL because it's built on top of proven rock-solid foundation of TimescaleDB, which obviously, as you know, is a time series database built on top of PostgreSQL. And therefore, as a result, it lets you query the data using full SQL. It also gives you a lot of other benefits like reliability, high reliability. You can create replicas. You can benefit, you can even store if you want, other types of data inside the same database. So it gives you a lot of, obviously having a, PostgreSQL as a backend to it gives you a lot of advantages. And in the demo, we will use SQL extensively to derive insights. On top of OpenTelemetry, Promscale also integrates with Prometheus for long-term metric storage and analysis. And it includes support for PromQL as well, the Prometheus query language. This is just the high-level architecture of Promscale. You can see that Promscale, uses TimescaleDB to store the data. You can natively ingest Prometheus metrics and OpenTelemetry traces. And you can use Grafana, Jaeger, or any tool really that speaks SQL to query and visualize your data. Okay, so now let's take a look at the architecture of the demo environment that we will use. As I said, the demo environment is available on GitHub. If you want to deploy it yourself, it's very easy. You can just basically copy and paste the 3 commands in this slide in a terminal. And the only thing is that the only requirement is that you must have Docker and Docker Compose installed in your system, and Git as well to do Git clone. And with that, you'll be able to get up and running in a few minutes. You'll have to wait a few minutes, and you will get the demo environment up and running. Already, with everything already set up and connected for you to start exploring your traces. This is the high-level architecture of our demo system. It's a password generator that has been over-designed as a microservices application. Okay, it doesn't make a lot of sense for a password generator like this, that is the only thing it's doing, you make a request and it gives you a random password, to be built as a microservices application, but is a simple example that people understand, and so it's easy to relate to it and understand how it works. Then the microservices application has been connected to an OpenTelemetry observability backend. Okay, it has a load generator that makes requests to the generator service, and then the generator service calls the upper, lower digit, and the special services to get random uppercase, lowercase digits, and also special characters to build a password. The lowest service is written in Ruby, and the rest are written in Python. All services have been instrumented with OpenTelemetry traces, and they send those traces to Promscale via an OpenTelemetry component called the collector that, we will not get in detail, what it is, but I encourage you to check it out. It's a very cool connector to help you collect telemetry from different systems and then process it and send it to a bunch of different backends. And the demo environment also includes Grafana. Already, again, everything is already connected and set up, and Grafana has been set up with a number of dashboards that we will use in this session to visualize the data. Okay, so now let's jump into the demo. I'm gonna open Grafana here. One sec. Hop. Okay. And so we have a number of dashboards that we've created and have been pre-created for this demo. We start with a very simple example. Okay, we want to say, look, using traces, we want to get what are the requests per second that are made to our application. And by the way, because our application, the only entry point is the generator service, we're going to be basically querying just all the requests that go through the throughput of requests through the generator service. So how do we do this? Let me show you what's behind. We're using a standard Grafana time series panel. And this is the query, a fairly simple query, okay? So we're creating time buckets of 1 second, and we're counting the number of rows in this bucket. And this is the table, is actually a view that we're querying, it's a span view. And this is a view that is exposed by Promscale to make you, so basically you send telemetry, that you send traces to Promscale, and Promscale automatically has built a schema for storing them that is optimized for performance and high cardinality and scalability. And there are a bunch of tables that are involved, but it exposes a view, this span view, to make it easy for users to query. And the other thing that we do, the only condition that we apply to it is that parent span ID is null. What this means is that Spans, as you if you follow the previous session with Scott, a trace is a sequence of a span, a hierarchy of spans. The first span in the trace typically captures the entire the time it took, to run the entire trace, okay? Because all the other spans are in it. So if you think about it, the first span in that trace is called the root span. It doesn't have any parent, and so you can use that to understand how many requests to that endpoint, how many traces at the end there are, many requests have been made to the endpoint. And the other thing that you can use it for as well, we won't use it here, but you could also use it for understanding the duration, the total duration of those requests, encompassing all the different operations that are needed across the microservices to deliver, on each individual request. And so by checking on parent ID null, we're just, okay, we just want the top level. We just want to count how many times there's been, how many traces there are stored in the system at the end of the day. And so we get, and this is what we get. We plot that over time, and we get, the request per second. That is a, fairly simple example. Let's look at another one, another example that is more interesting. That is something that we can do, because the previous one, you could probably do it with metrics. This one is a lot more complicated typically to do with metrics, which is, if you look at this table, we're showing error rate, but we're showing error rate per service and also per operation, per individual operation. And some of those operations are happening, are inter-service operations, is things that happen just within a service. Some of those operations is a call from one service to another. And by looking at this, we can quickly see that, okay, this one, the upper extra process upper operation in the upper service is the one that has the highest error rate. So very quickly we see, okay, there are a bunch of errors in the system, but this is probably the service, I should go check in first if I wanna reduce the number of errors. Here, this is the same thing, but plotted over time. And so if we look at this query very quickly, we'll see it's again, we're querying the span view. And in this case, what we're doing, you see these conditions here is because there are these variables that we use in this dashboard at the top. So we use that so you can sell. If you want to filter down what is shown in the dashboard to a specific services and operations, you can. But the only thing interesting here is this. So we do a count on the number of spans, and we're grouping, as you see, by service name and span name. A span name is akin to an operation, and so we're grouping by service name and span name. And here we're counting how many spans have a status code of error, okay? And we're using this as a subquery. So at the top, we're just computing the ratio, okay? Here we're counting how many spans in total there are, grouped, by its service name and span name, and then we just do we just divide the two and we get the rate. And that's what we're saying here. Okay, let's look at more interesting stuff. Request durations. Again, so here we can build, because we have all in this case, we're not downsampling or anything. We have all the data. We can build a 100% accurate histogram of request durations, which is what you see here. And what we realize, just by looking at this, we see, okay, the majority of our requests are delivering less than approximately 2 seconds, but there are some outliers. There are some that they take, even more than 30 seconds. And if we go below here, we see, again, because we have SQL behind the scenes, we can run a query that retrieves the slowest request. So let's take a look at what the query looks like. It's, again, very easy. We do a select, again, on the span view. We're looking, again, at, entire traces, not individual operations, but entire requests that go through the system. And so that's why we're using parent span ID null in here. And we're just ordering by the duration, of those traces. Descendant, limit 10, so we retrieve the top 10. And we're doing some magic, interesting magic here. We're doing this replace, okay? And here, trace ID, we're replacing, basically removing dashes, because we store trace ID as UUIDs, and they come with dashes. But we remove them because then we can do some magic and have this link that when clicked, you can actually, Grafana provides a way to visualize an individual trace, so that you can understand the hierarchy and the sequence of operations and where things may have been wrong. What is slow? In this case, we're looking at the slowest traces. So what is slow? And very quickly, again, you don't have to copy and paste or anything. You click, it's everything within in Grafana, and you can jump and investigate that specific trace that was slow. And if you look at the detail, you'll see that if you look at the hierarchy, that there are a lot of things that are very fast, microseconds or milliseconds. There are some of them are long, are taking a long time. And if you look more specifically, you'll realize that always what takes time is this digit, random digit call. It's always the random digit call that is, the slowest thing in the hierarchy. Again, here, random digit call. So very quickly, you've identified that probably there is a problem, at least in this trace. And if we look at other traces, there's probably a common problem there. Random digit is slow. Again, very quickly, you can go identify where the problem is, in which operation, in which service, and you can go and go improve, look at the code and improve it. Okay, let's go back to our other dashboard. And now let's look at things even more interesting. And that is when it gets really interesting. This is a service. This is showing a service map and how the different services are interacting with each other. So with this, what we're seeing is that which service is calling which service. And okay, everything seems normal. Okay, the generator service is calling the digit service, is calling the lowest service, the special service, and the upper service. But very quickly here, we can identify there is something there is something wrong, something that doesn't make sense, which is that the lowest service is calling the digit service. And that number here, because of the way we've constructed the query, is showing how many requests are being made. Okay, this is the time point that I selected. In the last 5 minutes, there were 2,600 requests from the lower service to the digit service, and the generator service more or less about the same. So why is there so much traffic here? Probably there is a problem. Okay, and it's something that we could again go and check and see what's happening. So how does this work? How do we do this? So we're using a new visualization from in Grafana that it's currently in beta that is called the node graph. And the node graph expects two things. It expects a query to return that returns the list of nodes, the circles that you see here, and then a query that returns the list of edges. So that is the arrows that you see in here. And so if we look at this query is just retrieving all the different services. Okay, so it does a select on the view, is grouping by service name, and ID and title are things that need to be returned. Okay, the columns that you return need to have these names for the node graph to work. The title is what's shown underneath the circle. And then the second query returns the arrows. And as I said, so the relationships between the services. And this is something that is usually impossible, with the limited query language that other observability backends provide. But because we can leverage the full capabilities of SQL that are provided by Postgres, we can do joins. And in this case, if you look at what we're doing, and maybe actually I'll move to another editor to make this to make this easier. This is the query for the this is the query that we're doing for the edges. And so if you look at it, we're doing a join. Okay, we're joining the span view with itself. Okay, so we're joining the span view with itself, and we add two additional conditions. This while not strictly needed, we still add trace ID equal. The trace ID are the same. In theory, just with the span ID, it would be enough. But we do this just to make sure that the span ID, there is no collision in case there is collision in the span ID. But the important part is this. So what we look at is that the span ID of the P, the parent span, is the same as the parent span ID of the kid or the child span. So we are basically looking at relationships. And the other thing that we look at is that we want the service name from both to be different, so that we remove inter-service calls. Okay, this is only returning calls in between services. So again, it's something really cool because it's something that would be really it's really hard to do with other, maybe in most cases impossible with other observability backends. The other thing here that we do, we do the same thing, but we do this in a table, and we collect some other stats that are interesting. It's the number of calls. And here, very quickly, we can see that the total execution time was, is where most of the time is spent. We see, okay, the generator service calling the lowest service, and the generator service calling the digit service, and the lower service calling the digit service, which are, in minutes, in this 5 minutes here. And so, given that the lower service calls the digit service, most likely the slowdown, we saw it before, is in the digit service. Okay, I don't know. I'm not sure how we're doing on time because we started, a bit late. But I maybe just show one last example that I find really cool, and then I'll be done. Upstream spans.
You're doing good. Sorry, I just popping in and say you're doing a good job. One last example is perfect timing.
Okay, excellent. Thanks, Brian. And so let's pick the digit service, for example. And so yeah, if we look at this, so what this is showing, so I've selected the service digit operation / so it's this circle here. What this is showing is all the upstream dependencies. So it's basically retrieving all the traces where the digit service is involved, and is calling, recursively navigating the tree, the sequence of calls, until the digit service, but backwards. Okay, so that we can reconstruct a tree and we can see that, okay, so the digit service is called by the digit method in the lower service, and it's called, by the generator. So that's basically the tree. But we see, we see two paths. So one is from the generator to the digit service, and another one from the generator to the lower service. How is this useful? Imagine that you're in a situation where you see a sudden increase in the number of requests to a specific service, for example, but you don't know what's causing that. And in a microservices environment, this may be really hard to figure out, So with a map like this, you can actually understand, okay, what is calling my service, and how often are they calling the service. So that is actually really really helpful from that regard. And so if we look at the queries behind the scenes, again, the node and edges, and if we look at it very quickly, I have them here. This is what we do. So we do a query, and we use something really interesting, which is a recursive query. Okay, so we run first this query, and the results of this query are injected, in here, into this query. And so if we look at it, what this is doing, this is looking again at is navigating up and looking, at the parent. So it's retrieving, okay, the results that we got from the first query are here in X, and what we look is for where the parent span ID is the span ID of S, which is what we're joining with. And we're returning the parent span in this case, and all these results get injected again in the same query. And it does this again and again and again and again until this query returns no results. Okay, and finally, from all those results that were collected, all the hierarchy of results, this is what we're projecting. So we project an ID, which is the service name and span name. And then a few pieces of metadata that we show in the map. And here the query is very similar, but in that case, we're calculating the edges, so we're projecting some additional information, but it's the same. It's the same join happening here. Okay, and so with that, I'm just gonna encourage. So we've seen that OpenTelemetry, Promscale, how you can use OpenTelemetry, Promscale, and Grafana to get invaluable insights, thanks to the power of full SQL support. And I encourage all of you to download the OpenTelemetry demo today. All the software we've shown is available on GitHub and it's free to use. And if you have questions about Promscale or the demo environment that we've shown today, we're available in the Promscale channel on our Slack community. Thank you so much. And, I really hope to see you soon on our Slack community.
Awesome. Ramon, every time you show those dashboards and I think about what's going on behind the scenes, it just excites me so much. It's so fun as someone who loves SQL, just seeing that work. So your team's done a great job. Thank you for that. We actually have like almost gotten back on time here. So even though we dropped, I did just want to ask real quickly. So, as we're adding an OpenTelemetry, people that might already have been doing some of this, and if they want to start to incorporate Promscale in some way, what are some things they might need to think through?
Yeah, so on the OpenTelemetry side, something really interesting is that for the demo, we used manual instrumentation. But something really cool is that OpenTelemetry does provide auto instrumentation. Okay, so you can actually use libraries without changing your code for a number, not for all languages, but for languages like Ruby or Python, Node, Java. You don't have to change your code. You can use those libraries and very quickly get your systems instrumented. And then you can leverage Promscale has native support for OpenTelemetry, so you can send all those traces that get collected to Promscale. It's a good way to get started, and then from there you can start looking. Okay, do I have more needs for instrumentation? And you can add manual instrumentation on top of the auto instrumentation. It helps you get started much more quickly than if you had to do everything manually.
Great. Very cool. Well, thanks so much. Excited to see what else is coming from your team. I know we'll be talking more about observability in the next month or two. As we said, this is, streaming today is kind of a culmination of a week of releases, or what we call always be launching around Timescale Cloud, our hosted service. And we will have one of those weeks coming up in the near future for observability updates, improvements, and features soon too. So excited for that.
Yeah, really looking forward to that.
Great, Ramon. Thanks so much. Have a great day.
Okay, thanks.